In the previous session, we had a discussion over different theories of light, among which Christian Huygens said that light travels in the form of wave. So in this session, we are going to discuss in detail about this Huygens wave theory. So in his theory, he has given a geometrical construction for the propagation of wave. That means he was able to determine the position of the wave in a later time t. So that's why he has designed some mathematical construction. That's why this theory was very important. So before knowing the Huygens wave theory of light, let us know some of the basic things, because without this basic knowledge we cannot understand this Huygens wave theory of light. So I already told you, according to Huygens, light travels in the form of wave. Then how does a wave propagate in nature? So this is what we should know before knowing the Huygens wave theory. So for the wave propagation, we can give many examples in nature. There are a lot of examples we can give for the propagation of wave in a nature. So a simple example I'm gonna explain. So you can see number of people are standing in a line on your screen. So this is a simple example I want to discuss for the propagation of wave. See, there is a lot of persons who are standing in a line, and you can see the person who is standing at the last at the end of the line is pushing the person who is standing next to him. So what happened is, he is pushing the person who is standing in front of him. So the person who is standing in front of the last person, he experienced that push. So he transferred that push to the person who is standing in front of him. That's why what happened is, so whatever the force that applied by the person who stand at the end of the line is been transferred to all the persons who standing in front of him. So finally, whatever that force that he applied will be transferred to the person who standing first in the line. But if you look at the picture, the person who stand in the first line, he is standing still in his position. So he is not bending, he is not leaning. I mean, he is not changing his position. That's why whatever the force that has been applied by the last person is transferring from one person to another, and whatever that energy is decreasing as it moves from last person to the first person. So the first person experience only a kind of jerk. He doesn't change his position. See, in this way, in a nature also, the disturbances will be transferred from one particle to another. See, if we talk, it travels, the sound waves travels in the form of wave. So if we talk, the disturbances produced will be transferred through the nature. So the particle present in the nature will transfer these disturbances, like what we discussed in this example. See, that person is disturbing, and that disturbance is transferring to the person who is standing next to him, and the person who experienced that disturbance, he is again transferring it to the next person. So it is continuously transferring to the persons who is standing next to them, and the person who is standing in the first in the line, he experiences only a kind of jerk. He will not move from its position. That means whatever the energy, whatever the disturbance that is transferred, will gradually decrease when it move to some distance. So in the similar way, the waves in a nature or the disturbance in a nature will be transferred from one place to another with the help of particle. Like the persons are transferring these disturbances from one place to another. So in this way, the wave propagated in nature. So for the propagation of wave, there should be particles. So that particle will only transfer the disturbances. The particle remain in that position itself. Only the disturbances will transfer from one place to another. So this is what we can clearly understand from this example. I already told you we can give many examples for the propagation of a wave in a nature. We can also see propagation of wave in a water. See, if you throw a stone into the water, water waves will be produced, and water waves will travel in that surface of water. So it will travel because of the water particles. So those water particles transfer these disturbances and without changing their position. So let us also see one more example for the propagation of wave in a nature. Here we can see a water collected in a container, and there is a water tap, and there is no disturbance in that water. Now let us put a drop of water into this collected water. See, so as a drop falls on this collected water, disturbances will be produced, and these disturbances are transferring to the some distance. You can see it. Again, let us drop one more drop of water. See, this is a disturbance, and that disturbance is transferring to some disturbances, some places because of the water particles present in the nature. So let us view from the top portions. So now we are viewing in the side portion. So this will look like this. Let us see from the top portion. See, from the top portion it will look like this. See, this is a water wave which is transferring from that place to the another place, and this is because of the particle present in the nature. So let us see one more example for the propagation of wave with the help of particle using a sound system. See, this is a sound system. See, you can see number of particles present here, and this is a speaker, and let us see. So we have made disturbances. So a sound wave is produced. See, the particles are transferring that wave to one place to another. So here this is a source, and that source producing a sound wave, and that wave is that disturbance is transferring from one place to another. Let us also see the in a waveform. See that the disturbance are transferring because of that particle. See, particles again coming to their original position only by transferring that disturbances. So in this way, the particles present in nature will transfer these disturbances from one position to the another position without changing their position. So the particle will not change their position, only the disturbance will be transferred. So this is what we can understand. So this is what we understood from this animation. So in this way, wave will be propagated in nature. So now let us look at about the Huygens wave theory of light. So while explaining the Huygens wave theory of light, we will use some notations. So we will represent wave in the form of wavefront. Then we should know what is a wavefront. See, you can see the waves which are coming from a source, and that waves will produce us some disturbances, and at some places the disturbances will be maximum. See, we have drawn the waves in the diagram. You can see it. Let us say these waves are produced from source, and let us mark some points on this wave. So you can see this. You can see the points, that is yellow points we have marked on this waves, and at these points the disturbances are equal in all the waves. So let us draw a line to such points, and that line can be called as a wavefront. So all these points, the yellow points, all these points are at an equal distance from the source. For example, if we kept a source here, and all these points are at the same distance from the source, and all the disturbances are same in the magnitude at this place. So if we draw a line to such points, then that can be called as a wavefront. So wavefront, it can be defined as, it is the location of such points which oscillate in same phase. So same phase means they are having the same magnitude of disturbances. That means they can have a same maximum value as well as they can have a same minimum value. So it is known as a wavefront. It can also be defined as, it is the envelope of constant phase. See, at these points they will have the same phase, they all have the same value of disturbances. At these points also they will have the same value of disturbances. So if you draw a tangent, if you draw a line, if you say, if the envelope of, if the surface of all these points can be called as a wavefront. So in explaining the Huygens principle, we will use a notation of wavefront instead of drawing these waves. So if you say wavefront, this is related to the wave. See, there are different kinds of a wavefront we can see. If you have consider a point source, then this point source will emit the wave in all directions. That is why they will produce a spherical wavefront. And if you take a linear source, a source in a straight line, if I take a one tube light, then that can be produces a wave, and the wavefront produced by it can be called as a plane wavefront. And if the source is kept at a infinity distance, although if it is produces spherical wavefront, it will look like a plane wavefront, because since it is placed at a very long distance. So these are the some types of a wavefront. So that is why if there is a point source means if you kept a torch in the center, and that from that torch the light will travel in all directions in a 360 degree, so that the disturbances will be produced in the nature, and that disturbances are transferred with the help of particles. And we can also draw some wavefront. So wavefront means it is a location of the points which oscillate in phase, which will oscillate in the same magnitude. And if you draw a line to such points, which will give a spherical wavefront. So in the linear source means it is a, if the source is in a straight line, or if I take a tube light, that will produce a plane wavefront. So in a similar way, if there is a source in the infinity, that will produce a plane wavefront. So these are the some examples of wavefront. Now let us discuss about this Huygens principle. So I already told you, Huygens said that light travels in the form of wave, and he has developed a geometrical construction for the determination of new wavefront in a later time. It means that if you know a wave in a time t, in a t is equal to 0, then it is able to determine the new wavefront in a later time t. So that is why he made a geometrical construction for this determination. So let us see how Huygens said that light has a wave nature, how light travels in the form of wave. So to explain the Huygens principle, we have to take a point source. So it is already there on the screen. Considering a point source which emit the disturbances in all the directions. So you can see on the screen there is a source which emit the waves. So this is a point source, and this source is emitting the waves in all the directions in the form of waves. And here we using a notation of wavefront. So I already told you the point source produces a spherical wavefront. So that is why we can see a spherical wavefront here. So this is one spherical wavefront, that is a F1, F2. There is another spherical wavefront D1, D2. There is one more spherical wavefront, that is G1, G2. Then what Huygens predicted in his theory? What he has explained in his theory? Let's see. So he has considered one source and which emit the waves in all directions. So whatever the disturbances produced by this are maximum are in a phase each other can be called as a wavefront. So you can see the wavefront here, that is F1 and F1, F2, which is a one wavefront, one spherical wavefront. So that you can see on the screen. So this wavefront, which is a F1, F2, should give or should travel to some distance. So after some time t, that wavefront will occupy a new position. So that is what you can see, another wavefront, that is G1, G2, which is actually the new position of the previous wavefront, that is F1, F2. So as a time t elapsed, that F1, F2 will reach the position G1, G2. So let us see how this Huygens explained this. So according to the Huygens, he said that each point on this wavefront F1, F2, see this F1, F2 has many points, and each point on this wavefront is a source of secondary disturbances. He said that if we take a point on this wavefront F1, F2, and from that point there will be number of waves will be transferred from that position, and wavelet emanating from these points, wavelet means the waves which are emanating from the points that we have considered in the wavefront F1, F2, and they will move in all the directions, and these waves produced from the wavefront F1, F2 moves with the speed of light, and that can be called as a secondary wavelets. So he said that if we consider some points on the wavefront F1, F2, and from that point waves will be generated, they will again produce a wave. So they will move with the velocity of light, and the waves can be called as secondary wavelets. And if we draw a envelope, if you draw a line to all these secondary wavelets, which are all produced from these points, you can see the points also on the wavefront F1, F2. You can see one point here, you can see another point over here, you can also see one more point. So from these points waves generated, and we have drawn an envelope or a line or a tangent to all these wavelets, and which gave a new position of the preceding wavefront. So which is the preceding wavefront? That is F1, F2. That is F1, F2. So in a time t, the F1, F2 to travel will travel a distance of v into t. How to say they travel a distance of v into t? Let's say the waves produced from the wavefront f1 f2 are moving with the speed that is a v. So they have took time t to reach this position. So the distance traveled from this position to the another position is v into t. So we have used the formula of speed, which is speed is equal to distance by time. So using that equation, we can determine the distance that is traveled by this wavefront. So according to the Huygens, again the disturbances will be produced in the wavefront, so that the disturbances again will be transferred to some other distance. So in this way, Huygens proposed his wave theory. So this is a principle of Huygens. He said each point on the wavefront is a source of secondary disturbances. Means each point, if you take you can take many points on the wavefront, that is f1 f2 on the f1 f2, and each point again produces some wave. So that wave will move forward and they move with the speed of light, and whatever the wave produced from these wavefront, that is f1 f2, can be called as secondary wavelets. And if you draw a line or a tangent, or if the envelope of all the secondary wavelets will represent new position of this preceding wavefront in the elapsed time t. So this is how Huygens explained the propagation of wave in a nature. So let us see how he has constructed this. I already told you in the beginning that Huygens gave a geometrical construction for the propagation of wave. So let us see how he has constructed this theory. So he has considered that these waves are moving with the speed v in the medium. He said that for the propagation of wave, there is a medium. He has imagined a hypothetical medium called ether, and in this medium these waves travel with the speed v. So the new position of f1 f2, see this is f1 f2 is a one spherical wavefront at a time t is equal to 0. Okay, we have considered this wavefront. So to determine the new position of this wavefront in a later time t, so we can determine it by drawing a sphere which having a radius of v into t. I told you the distance traveled by this wavefront of f1 f2 in a later time t will be vt. So to determine its new position, we have to draw a sphere having a radius vt from each point that we have considered on the wavefront f1 f2. So then if you we have drawn there, you can see the part of a spheres that we have drawn here. See, this is a backward one, this is a forward one. So these waves are moving in this direction, and you can see the part of a spherical part of a sphere over here, and this is what we have drawn with the radius that is v into t. See, this is a radius which is v into t. Now what we have to do is we have to draw a common tangent to all these wavefront. So we have drawn a common tangent, that is g1 g2, that is a common tangent or a common envelope. So this gives the new position of the preceding wavefront, that is f1 f2. So in a later time t, the f1 f2 travel to distance of v into t, and its position you can see on this picture. So the new wavefront, spherical wavefront, is G1, G2. Again what happens? Again you can consider many points on this wavefront, that is a G1, G2. From that points again the waves will be generated, and that can be called as a tertiary wavelets. Again they will travel with the speed of light in that medium. Again if you draw a wavefront, again if you draw a envelope to all these wavelets, which will give again a new position of the preceding wavefront, that is G1, G2. So this is how Huygens constructed his wave theory of light. See, you can see sphere, you can see the wavefront, one is G1, G2, as well as you can see a wavefront D1, D2. See, Huygens said that wave always travels in the forward direction. If there is no obstacle, if there is no reflecting surface, then the wave has to travel in the forward direction. So that is why there will not be any backward wave. So he said that there will not be a wavefront D1, D2. Although in this construction we can see the wavefront D1, D2, he said that since the waves are moving, advancing in the forward direction, he said that the amplitude of these waves are 0, the backward waves is 0, and he is able to say that these amplitudes are 0, but it was unsatisfactory. So that it become a drawback to his model. So let us see his drawback. So Huygens argued that amplitude of these secondary wavelets is a maximum in the forward direction. See, this is a waves where we have drawn the wavefront at which amplitude is a maximum, and he said that the amplitude is 0 in the backward direction. See, we can see here. So he said amplitude of the secondary wavelet in the secondary wavelet is maximum in the forward direction, and it is 0 in the backward direction. So he gave reason that since the wave is traveling in the forward direction, there will not be a backward wave. So although he was able to prove it, but it was a unsatisfactory, so it will become a drawback to his model. So this is how Huygens explained his wave theory of light. So he also gave the geometrical construction for the propagation of wave.